Right. So, good afternoon, guys. So last week we were doing linear programming, right? Basically limiting fact analysis. We completed limiting fact analysis, and then we moved to. So in limiting fact analysis, we learned how to do the optimum production planning when there is only one constraint, and then we moved to linear programming, where we learn to deal with multiple constraints, resource constraints and demand constraints, right? So uh, we went through linear programming, guys. We did the first steps. We completed everything up to the point of drawing the graphs, right? The final step we did was obtaining the coordinates. So what I want you all to do now is to take few minutes and go through uh, the linear programming area that we did, right? We directly went into the question, right? Uh, and in that question, we completed, right, from step 1 all the way up to step 4, right? So what I want you all to now do is quickly go through these steps, right? Go through the question that uh, we did for through the steps that we did for this question. I'll give you a few minutes, quickly go through it. Okay, guys. Right. So we completed up to step 4, up to the point of getting the coordinates, right? So now everyone is fine on this. Step 1, defining the variables. So X represents the number of X units, Y represents the number of Y units, then C is the contribution. Then we constructed the objective function. Then we formulated the constraints, both resource and demand. Then we obtain the coordinates for both resource and demand. So for the purpose of obtaining the coordinates and drawing the graph, instead of saying less than or equal, we assume that the full amount of the resource will be utilized and the full amount of the demand for the product will be supplied. And then we use the sign equal instead of less than or equal, right? That's how we got the coordinates. That's where we stop. So the next step is, guys, drawing the graph. Okay, so now let's learn how to draw the graph. Let me share a slide on that. Hold on. Right, now I want everyone to focus on this properly. Yeah, right, focus. This is very, very important. If you don't understand, it will be a problem. Okay, right. So for the same question, now we are going to draw the graph with the coordinates that we have, right? With the coordinates that we have. Hold on. Right. So for this question, these are the coordinates that we developed last week for build x coordinate, y coordinate for all three, build, program, and test, and the demand constraint x and y. Okay. So in your tute, I have given a graph, right? A graph that you all can use to draw uh, draw the constraints, right? So now what I want you all to do is, first, before we get into the graph, I want you all to change the scale of the graph, right? I want you all to change the scale of the graph because uh, sorry, the in the tute the graph is given like this, right? Going from 100, 200, 300 up to 2000 on the y-axis, 200, 400, 600 up to 2200 on the x-axis. So I want you all to change the graph into this. Change the graph into this scale, y-axis, number of y units, x-axis, number of x units, 20,000, 40,000, 60,000, 80,000, all the way up to 200,000. That's the y-axis. X-axis, again 20,000, 40, 60, all the way up to 120,000. So change the scales of this, guys, right? I want you all to change the scale of your graph into this, what I have given here. Do it quickly. Yeah, change the scale of the graph into this. Y-axis 20,000 all the way up to 200,000, gaps of 20,000, 20, 40, 60, 80, likewise all the way up to 200,000. X-axis 20, 40, 60, 80, 100, 120,000. That's the x-axis and the y-axis scales. Okay, guys, done? All okay? Right. Now, first I am going to teach you how to draw one resource constraint and one demand constraint. Now, after I teach you all how to draw one resource constraint and one demand constraint, I want you all to complete the rest, right? I want you all to complete the rest. Okay. Now, first I'll teach you the demand constraint, right? I'll show you how a demand constraint is drawn. So look at product X. Product X, the coordinate is X equals 85,000, right? X equals 85,000. Now, for X, for the demand constraint, guys, there is only one coordinate. right? There is no x coordinate and y coordinate because it's a product, no, not a resource. Now in resource, one resource is used to produce product x as well as product y. So therefore it will have an x coordinate as well as a y coordinate. But demand is only for one product, no? So there is only one axis, right? So the maximum amount of product x that I can sell is 85,000 units. That's the meaning, right? So that means that you can't go beyond 85,000, right? So how you indicate in the graph is, guys, x equals 85,000. So product x, right? Product x is represented by x axis. So here you will see number of x units, and product y is represented by the y axis, number of y units. So if we are saying the maximum demand for x is 85,000, right? So how you draw is x equals 85,000 like this. Maximum demand for x. So you draw one line at 85,000 to the top of the graph like a wall. You can't go beyond 85,000 because that's the maximum amount of product x that you can sell, right? This is at 85,000. Clear? X equals 85,000. Clear? Any question? Right? So you block the x-axis at 85,000, indicating that you can't go beyond that because there is no demand for the product. Clear? So similar thing you will have to do at for y-axis, number of y units. So the demand constraint for y, it was 66,000, right? So at 66,000, you have to block the y-axis so that you can't sell more than 66,000. Clear? So that's how you draw the demand constraint. Now let's take a resource constraint. Let's go back. Let's take build. Build, there will be an x coordinate and a y coordinate because build is used to produce both products. Now, how did we get the coordinates? We got the coordinates by assuming number one, if the entire amount of build resource is allocated only for product X, how much of X units can I produce? And if the entire amount of build resource is allocated only for product Y, then how much of Y units can we produce, right? So what you will see is, guys, the x coordinate and the y coordinate, right? Now in one, how did we get the x coordinate? We said if y is equal to 0, how much is x? That means if we produce 0 y units, how much of x units can we make, right? So at that coordinate of 75,000 x units, the number of y units should be 0 because the entire resource is allocated to x only. Then on the other side, we assume if the entire resource is allocated to only product Y, how much of Y units can we produce? 90,000, right? So at 90,000 Y coordinate, number of X units has to be 0, isn't it? Because the entire resource is allocated only for product Y. Clear? So the logic, right? So let's see. So this is the demand constraint. So build coordinate was X is 75,000, Y is 95,000. So how do we draw that? Like this. Build constraint. X at 90,000, sorry. X coordinate at 75,000, Y coordinate at 90,000. Clear? X coordinate at 75,000, Y coordinate at 90,000. Clear? So this is how we draw the constraint for build. Now what you will see is like I told you earlier, right? Like I told you earlier, at 90,000 Y units, the number of X units are 0. Here, can you see? 90,000 Y units at this point, X units are 0 because the entire resource is allocated to Y only. Then at X is 75,000, here x-axis coordinate 75,000 units. At this point, number of Y units you will see are 0 because we assume that the entire resource is allocated only for X. So always it will touch the x-axis as well as the y-axis, right? Clear? When it touches the x-axis, the number of Y units will be 0 because we assume that the entire resource is allocated only for X. That the point where it touches the y-axis, the number of x units will be 0 because that is drawn assuming the entire resource is allocated only for y. Clear? Any questions? So this is how you draw a demand constraint as well as a resource constraint. Now what I want you all to do is to take few minutes and draw the rest of the coordinates. First take these two down. Huh? First in your graph, take this demand for x and build time down. This is how you draw it. And I want you to complete and draw the line, draw the constraint lines and complete for demand for y, program time and test time. Do it. Draw the lines, draw the constraint lines for demand for y, program time and test time. I'll give you all a few minutes. Quickly do it. Quickly do it. Draw it in your own graph, right? Take these two down and draw the rest. Okay, right. Now let's draw the other lines. So next, let's draw the maximum demand for Y. So the maximum demand for Y is how much? Y equals 66,000, right? So how there is only one coordinate for that, only the Y coordinate. So just like the X maximum demand for X, maximum demand for Y will appear like this. Clear? At 66,000, a flat line across the graph indicating that you can't go above 66,000. Maximum is 66,000. Clear? Any questions? So that is the maximum demand for Y. Next, let's draw the uh, uh, program line. So what are the coordinates for program, guys? Yeah, what was the coordinate for program? X coordinate is 105,000, Y coordinate is 120,000. For test, Y coordinate is 72, X coordinate is 72,000, Y coordinate is 180,000, right? So this is program. 120,000 Y, 105,000 X. Clear? Program time. Similarly, test will be Y 180,000 X 72,000, right? So this is how your graph should look like, guys. Yeah, this is how your graph should look like. And label all the lines. Are good if you can use different color pens. If not, that's also fine. Label all the lines. Test, program, build, maximum demand for X, maximum demand for Y. So this is how your linear programming graph should look like. Any questions? Are you all clear on this? How to draw the linear programming graph? Any questions? All okay? Right. So basically we draw the lines for the coordinate. Okay. So this is the graph. But still we haven't see the end objective is, guys, to find the optimum production plan, the profit maximizing production plan. So that part we haven't done yet. Now from this graph, that's where we are going, right? But to do that, you have to draw all the constraints. So we drew all the resource constraints, build, program, and test, as well as the demand constraint, demand for X, demand for Y. Okay, right. Next, the next thing to do is, guys, in the whole steps of finding the optimum production plan, the next thing is something called the feasible region, right? Something called the feasible region. Now, feasible region, right? Now listen to this carefully, guys, right? Listen to this carefully. Feasible region, right? Feasible region is basically a diagram that is drawn by connecting the first corners of the graph. Okay, it is a diagram, right? Listen carefully. It is a diagram that is drawn by connecting the first corners of the graph. It is called the feasible region. It is called the feasible region, right? Now, why is feasible region important to us? Because, guys, the optimum production point, right? The optimum production point is inside this feasible region, right? The optimum production point or the profit maximizing production point is inside this feasible region. Therefore, feasible region is very important to us, right? What is the feasible region? It is a diagram that is drawn by connecting the first corners of the graph. Okay, the first corners of the graph. It is called the feasible region, right? So how do we find out this feasible region, or how do we connect the first corners of the graph, guys? I'll teach you. You have to focus, huh? Focus on this properly, right? Focus on this properly. So, what you have to do is you have to first start with, right? First start with, I'm using this laser pointer. You have to first start from 0, right? Always first start from 0, right? So 0 is the first corner of the feasible region, right? Always 0 is the first corner of the feasible region. Always start from 0. So 0 I'll call as point A, right? I call as point A, right? That's always the first corner of the feasible region. Okay, if you want to note anything down, please do, right? So when you start from 0, what you have to do is you have to move along the x-axis. Okay, not the y-axis, x-axis. Move along the x-axis, right? Move along the x-axis like this. So when you move along the x-axis like this, you will hit a corner. What is a corner, guys? Yeah, what is a corner? A corner could be two things, right? Listen to this very, very carefully. A corner could be two things. A corner, number one, right? Number one, a corner could be where a constraint line intersects with x-axis or y-axis, right? Where a constraint line, right? A demand constraint or a resource constraint intersects with the x or y axis, right? It could be a point where the a constraint, demand constraint or resource constraint intersects with the x axis or y axis, right? So when you start from 0 and when you move along the x axis, right? When you move along the x axis like this, what's the first corner that you hit? The first corner that you hit is right here. What is this? This is where the test constraint intersects with the x-axis. Clear? The test resource intersects with the x-axis. Clear? So I told you that there are two types of corners, right? The first one I told you, a corner could be where a constraint intersects with x-axis or y-axis, right? The second type of corner that we have, is where two constraints intersects with each other, right? Two constraints intersects with each other. So first type of corner is where a constraint intersects with an axis, x-axis or y-axis, like we have right here, right? Second type of corner is where two constraints intersects with each other. Two constraints crossing each other is also a corner. Understood? Either a constraint meeting the x-axis or y-axis. Number two, constraints meeting each other, crossing each other. Both are corners. Clear? Now, what is so special about the corner? Why is it important? Because you need to understand the meaning of this corner, right? Now, this is where this corner right here, this is where test time intersects with x-axis, or test time crosses x-axis. Clear? Now, what does it mean? What does it mean, guys? Where is it crossing the x-axis? It's crossing x-axis at 72,000, right? That's the coordinate of 72,000. Now, what does it mean, guys? It means that I cannot go any further, right? I cannot go any further. I have to stop here. Why do I have to stop here? Because it means that the maximum amount of test resource I have is over. Even if I allocate the entire test time to product X, the maximum I can produce is 72,000 units. Yes or no? Yes, that we calculated. So therefore, guys, this corner means that I can't go any further because the maximum amount of resource that I have is over. The maximum amount of resource that I have is over. So if I don't have any more resources of test time, can I do any more production? Can I produce? Because understand, what does the x-axis mean? What is the meaning of x-axis? Check number of x units, right? X-axis represents the number of x units. So beyond this point, can I go any further? No. Why can't I go any further? Because I don't have any more time of test department remaining for me to produce more X units, isn't it? I have reached the maximum amount of test time I have, or test department resource I have, and I can't go any further because I can't produce any more units without the test resource. So I have to stop from here. Clear? I have to stop from here. Any questions on that? Right? So understand, guys? So hitting a corner or meeting a corner is like hitting a wall. The resource is over. The constraint means the resource or the demand is over, and I can't go any further. I can't produce any more. It's over, right? So that means from this point, I can't go further in the x-axis, right? It's like hitting a wall. I can't go any further in the x-axis because the resource is over. Clear? The resource is over. I can't produce any more X units, so I can't go any further. So this corner I call as corner B. Clear? Corner B. So what do I do when I hit a corner? Now, when I hit this corner, which constraint am I hitting? I am hitting test time, right? I am hitting test time. So when I hit a corner, guys, or when I hit that constraint, I can't go any further. And what I have to do is, I have to now move along that constraint. A constraint එක උඩින් යන්න ඕනේ. Constraint එක පැත්තට යන්න ඕනේ, right? So when I hit B, corner B, which is test time, now I have to move along the test time like this, right? I have to move along the test time like this. Clear? I can't go to this side. So when I hit the corner, when I hit the constraint, I have to move along the constraint. ඒක ඒ පැත්තට යන්න ඕනේ, constraint එක පැත්තට. Like this. Until I hit the next corner. Now, I told you there are two types of corners. First type of corner where a constraint meets an axis, like this, right? Like corner B. The second type of corner is where constraints meet each other, or constraint intersects each other, like this point. Now at this point, what is happening, guys? Two constraints are intersecting with each other, test time and build time, right? Test time and build time are intersecting with each other. Now, so that is also another corner. Now, what does this corner mean, right? What does this corner mean? This corner means build time and build time, I have reached to a maximum level here, right? Build time, I have reached to a maximum level. So build time goes from the y-axis to the x-axis along this line, right? Now I am moving along the test time, and when I hit this corner, it means I have reached the maximum amount of build time and I can't go any further, right? Because it's like hitting a wall. The resources to produce, right? I don't have any more resources to produce above that level. Clear? So I can't go any further. So that means I have from this point, it means now I have reached the maximum level of build time. I can't go above that. I can't produce more than that because the resource is over. That's the maximum level. Clear? That's the meaning of hitting a corner. So this corner where test time and build time intersects, I call as point C. Understood? So now what did I tell you to do when you hit a corner? What did I tell you to do when you hit a corner? You can't go above that, right? And when you hit the corner, after that, you have to move along that line. Now here, what is now first initially from 0 when I went, I met the test constraint. So I moved along the test constraint until I hit the build constraint here. Now I can't go any further along the test constraint. Test constraint එක පැත්තට යන්න බෑ because I have reached the maximum level. That එක පාන්න බෑ. Right? Build time is over. I have reached the maximum build time. Now I have to move along the build resource. Right? From here, I have to now move along the build resource like this until I meet the next corner right here. What is this? Again, this is where two constraints are intersecting with each other. What are the two constraints that are intersecting now? Build time and maximum demand for Y. So when I hit this constraint, what does it mean? The new constraint that I'm hitting is maximum demand for Y. Maximum demand for Y is 66,000, right? So hitting this means that I have now reached the maximum demand for product Y and I can't sell any further. So when you meet a resource constraint, it means you are out of resources to produce more units, right? But when you hit a demand constraint like that, it means that I have reached the maximum level of demand for the product and there is no point of producing anymore. There is no point of producing that product anymore because customers won't buy and I will not be able to sell because I have reached the maximum demand, 66,000, right? And therefore I will not be able to sell more. So no point of producing. Clear? No point of producing. So I have reached the maximum level of demand for Y, 66,000 here. So the point where these two constraints are intersecting, I call as point D. Clear? Now, like I said, when you hit a constraint, you can't go any further. So I can't go any further along the build time. See, the point is, guys, there is still more build time left. Can you see? There is still more build time left. I can produce 90,000 units of product Y, but no point, right? I have to stop here. Why? Because even if I produce more units of Y, there is no point because the customer won't buy. There is no demand. I have reached the maximum demand. So I can't go any further. I have to stop. Even though I have a little bit of resource left, I can't go any further. Clear? So now when I hit the demand constraint for Y, I have to move along the demand constraint for Y because I can't go any further on the build time because I have reached a maximum demand. So I move along the demand constraint for Y until I hit the Y axis, right? So that means that's the final point of the diagram or the feasible region, point E. Clear? So basically, guys, the feasible region is where you start from 0, move along the x-axis until you come back to the y-axis, right? Until you come back to the y-axis and to 0. Yeah, can you see? I started from 0, move along the x-axis, came here, here, and back to 0. Clear? So always start from 0. Move along the x-axis until you hit the first corner, right? The first corner is normally, guys, where the constraint meets the axis because you're moving along the axis, no? So usually always your first corner will be where a constraint intersects with the axis. Then once that is over, you move along the test time until you hit the next corner. Next corner is where in this question, two resource constraint intersect, right? Hitting a corner. Any corner means you have reached the maximum level of resource or demand and you can't go any further. And once you hit that corner or constraint, you have to move along that constraint until you meet the next constraint, right? Then from that point, you have to move along the new constraint that you met, right? So here, when you move, we hit the constraint for demand for Y, and we move along that until we hit the Y axis. Clear? So that's how you draw the feasible region. Clear on how to draw the feasible region, guys? I'll give a note, of course, but are you all clear on how to draw the feasible region? Yeah. Like I said, why is feasible region so important? Because one of the points in the feasible region, now we have 6 points, oh, sorry, 5 points, no, A, B, C, D, E. One of these points inside the feasible region is your optimum production point, right? One of these points, A, B, C, D, or E, one of those points is your is your optimum production point. Clear? Right. Now, before I give the note, what I want you all to do is, I want you all to mark the points A, B, C, D, E. Color this area. Take a highlighter and color this area. Don't draw lines, huh? Because there is few more things to draw inside the feasible region, right? And your graph will be completely messed if you draw these lines. Color කරන්න යන්න එපා. Take a highlighter and fully color it like this. Fully color it. Otherwise, when we draw the other things inside the feasible region, your graph will be completely messed up. So fully color it like this and label it as the feasible region like I have given. Draw it properly. Yeah? So draw the corners, color the corners exactly. Me podi kääල්ල color කරන්න එපා මෙතන. You have to color it only up to the corners right here. Okay, do it. Okay, done. Okay, so let's exit this and then go to the Excel. So I'll paste the graph onto the next tab later, once we are completed with the graph. So I will write down a note. After that, you take this down. Huh? This is the first note. Then I will just take this first note down, guys. This one down until I put the next note. Take the first note down. Write in your tute where I have mentioned feasible region. If there is no space, then use your notebook. down the notes, guys. Huh? I'm giving a full, detailed, comprehensive note. Right, so lengthy note, guys, but this covers it all. Huh? Right, you read this, it's all done. You should take this down fully. If you don't have space in the area that I have given as the feasible region, use your notebook, right? But this note has to be there, very, very important, full comprehensive note, guys. Hmm? Take this down fully. If you all have any questions, please ask. I'll give you a few minutes to take this down. Right, let's move. So now that anyway, I'll be sharing the Excel as well. Huh? So clear on this, no? Feasible region. Then step 7. Step 7 is called, guys, constructing the ISO contribution line, right? The ISO contribution line, right? ISO contribution line means the alternative contribution line, right? Alternative contribution line. Now, listen to this carefully, guys. See, now examiner's answers, right? If you look at the revision kit, has a bit of a complicated method of getting this ISO contribution line. Now I'm going to teach you all a shortcut method, right? I'm going to teach you all a shortcut method which is very easy, but you have to memorize it, right? You have to memorize this method. I'm not going to teach you all the full logic of how this is obtained, right? Because then it's not required. It's going to be too deep, right? There are certain other theories which are not required. I'm going to teach you all this very easy method that you all have to memorize, right? Because examiner's method is it's time consuming and you might get a bit confused. So I'm going to teach this shortcut method. At the end of the day, you get the same answer, right? So basically guys, ISO contribution line means alternative contribution line, right? So this is an alternative contribution line, and I'm going to teach you all 3 steps of getting this, and could be obtained through the following 3 steps. Right? So what are these 3 steps? Step 1. Right? Step 1 is, guys, write the objective function. So the first thing to do is, guys, you have to write down the objective function, right? From where do we get the objective function? Objective function was found in, we calculated in step number 2. Remember, step number 2. Go all the way to step number 2. Here, objective function, right? Objective function was where we calculated the maximum contribution from X, maximum contribution of Y, and then we took the objective function as 30X plus 40Y, sorry, contribution or C equals 30X plus 40Y. This is the objective function. C equals 30X plus 40Y. That is step number 1. Okay. Step number 2, right? Listen to this carefully. Now the objective function is 30 into the number of X units, 40 into the number of Y units, right? That's how we have obtained it, no? 30 into the number of X units, 30X, right? X means the number of X units. Remember, in step 1, we define the variables. So X means number of X units, Y means number of Y units, right? So we defined it. So 30X means 30 into the number of X units plus 40 into the number of Y units, right? So X. So step 2 is, guys, for X and Y, we need to come up with a number, or we need to substitute a number, right? So the number that, listen to this carefully, yeah? We need to now give a number for X and Y. This number should be either 10, 100 or 1000, one of the 3. It should be either 10, it should be either 100, or it should be 1000, one of these 3. Okay, keeping in mind, okay, keeping in mind that the ISO contribution line has to be drawn inside the feasible region. Okay, it's a line that is being drawn inside the feasible region of the graph. Okay, so therefore, when we select the value for X, now if we select 100 as the value for X, now this is 30X, no, plus 40Y, no. So if we select 100 as the value for X and Y, we will take 30 and multiply it by 100. We will take 40 and multiply it by 100. And we should be able to draw it inside the feasible region. Okay. So step 2 is select a value of either 10, 100 or 1000 for X and Y, keeping in mind that that the ISO contribution line should be drawn inside the feasible region of the graph. This is step 2. Okay. So if we select 100, right? I'm going to show the full step here. If we select 100, or if we select 10, right? Let's start with the smallest value. If we select 10, if we select 10, then x 30 into 10, 300, y 40 into 10, 400. This is what it is now, guys. If we select 10 as the values for x and y, then x value or value of x coordinate will be 30 into 10, 300. Value of y coordinate 40 into 10, 400. Right? So this is how it comes. So now tell me, guys, 300 and 400, right? 300 and 400. Can we draw it inside this graph? Can we draw it inside this graph, guys? 300 and 400. Can you all tell me? Can we draw 300 and 400 inside the feasible region? So this is the feasible region, right? This is the feasible region. Can we draw 300 and 400 inside this? We can, but what's the problem? It is too small because the two axis starts from 20,000, no? The two axis starts from 20,000. So when it's starting from 20,000, guys, drawing 300 and 400 inside here is too small. We can't even see where is 300, 400 here, right? It's too small, right? So understand, you have to be practical also, right? So too small to draw in the feasible region. Clear? So we eliminate 10. So 10 is gone now. Now, if we select 100, what will happen, guys? Value of x coordinate will be how much? 300 in 13 to 100, 3000. Yeah, 3000. Value of y coordinate 14 to 100, 4000. Now let's go back to the graph and tell me, in this, is it possible to draw 3000 and 4000? You can, but again, what's the problem, guys? Too small, because the graph starts from 20,000, guys. When the graph starts from 20,000, drawing 3000 and 4000, it's a bit difficult, right? Not practical, isn't it? It's not practical. Clear? So that's a problem. Again, too small, because the graph starts from 20,000. So this is 3,400 will be too small. 3,000, 4,000 will be too small. Then let's select 1000 as the value for x and y. So if we select 1000 as the value, then it will be 30,000 for x, 40,000 for y. Now tell me, Now, is it possible to draw inside the feasible region, guys? Now, is it possible to draw inside the feasible region 30,000, 40,000? Yes or no? Yes. Yes, the graph starts from 20,000, getting 30,000 and 40,000 is very possible, and it is good size, also visible, and it's practically possible. Clear? So therefore, we will say it is the correct value to draw. It is the correct value. So we select the value of 1000. Clear? So then the value selected would be these two. Clear, guys? Value of x 30,000, value of y 40,000. Clear? So first step is to take the objective function c equals 30x plus 40y. Then step 2, for x and y, select either 10, 100 or 1000, keeping in mind that the line should be drawn inside the feasible region of the graph. So 10 was too small, 100 was also too small, 1000 was the perfect size, right? So we selected 1000. So the value of x coordinate came to 30,000, value of y coordinate came to 40,000. Clear on that so far? Any questions on that? Right. Step 3 and the final step is simply swap the values of x and y. Step 3 is simply swap the values of x and y. So basically, guys, values of x and y are how much? The values of x and y, swapping means marukaran, right? Swapping means marukaran, right? You interchange the values of x and y. So currently the values of x and y are x 30,000, that's what we have, y 40,000. Now after swapping values of x and y, the final coordinates of the iso contribution line are x coordinate. So when you swap x, now currently x is 30,000, y is 40,000. So you swap them, right? So then x coordinate will be 40,000, y coordinate will be 30,000. So these are the final coordinates of the iso contribution line. Clear, guys? These are the final coordinates of the iso contribution line. Clear? So step 1, write the objective function. Step 2, select either 10, 100 or 1000. So we selected 1000. Based on that, we got the value for x coordinate and the y coordinate, 30,000, 40,000. Final step, swap those values of x and y. So x was 30,000, now it became 40,000. Y was 40,000, now it became 30,000. Clear? So these are the final coordinates of the ISO contribution line, right? Like I said, guys, I'm not going to explain the logic of this because to go into it, there are a few other theories behind this logic, right? Which are a bit, uh, difficult for you all to understand at this stage, right? So like I said, just memorize this, right? Final method, swapping the values, because if I am to go into that level, I have to go into certain other theories that are not needed and you will get confused, right? If I go into it. So just remember this, right? So simple way, yeah? Very, very simple, nothing complicated. If you look at the examiner's method, it's very complicated to remember. This is very simple. Write the objective function, select 10, 100 or 1000. Once you select, you get multiply it by the contribution number you have. If you select 10, if you select 1000, it's 30 into 1000, 40 into 1000. So you got 30,000, 40,000. Finally, swap the values of x and y. And these are the coordinates of the ISO contribution line. Clear, guys? Any questions on any unclear areas? So this is what you have to remember, guys. Any questions? So now the ISO contribution line should be drawn inside the feasible region of the graph. Right. Take down these 3 steps, guys. Take down the 3 steps of getting the ISO contribution line. Right. So next thing is, guys, to actually come here. Right. To draw this. Okay. So now we have the coordinates for the iso contribution line. Next is to draw the iso contribution line into the graph. Right. So draw the iso contribution line, guys. Draw it like this. Draw it and label it as the iso contribution line. Do it. Okay. Right. Good. So now we have almost come to the point of identifying the optimum production plan, right? Optimum production point. Right. Now, guys, from this point onwards, how do you identify the optimum production point? Right. So what you have to do is, hold on. Right. So now what you should do is, guys, take a ruler. Take a ruler. Okay. Take a ruler and you have to keep the ruler on the iso contribution line. Iso contribution line එක උඩින් තියන්න. Okay. Keep it on the iso contribution line. Take a ruler and keep it on the iso contribution line. Fine. Right. So now look at what I am going to do. Huh? So, so what you should do is you have to keep your ruler on the iso contribution line and you have to move upwards like this. හරිද? මේ විදිහට උඩට යන්න ඕනේ. You have to move upwards like this, right? Now when you move upwards, don't do anything, just first listen. When you move upwards like this, the last point, right? The last point, now there are how many corners, how many points in the iso contribution inside the feasible region? You have A, B, C, D, E. So out of these 5 corners or 5 points, 5 corners, the final corner that is getting cut by the iso contribution line is your optimum production point. The last corner that is getting cut inside the feasible region by the iso contribution line is your optimum production point. අන්තිමටම කැපෙන කොන. මේ පහෙන් අන්තිමටම කැපෙන කොන. අන්තිමම corner එක. Right? Or in other words, the furthest corner in the feasible region. දුරම corner එක. තමයි optimum production point කියලා කියන්නේ. So you have to keep the ruler on the iso contribution line, move upwards, and the final corner that is getting cut by the optimum by the iso contribution line is your optimum production point. Clear? Okay. So now that we are here, right? Now we are here, no? So what you need to understand is, guys, already we have passed point A. Point A එක pass කරලා ඉවරනේ. පටන් ගන්නෙම from 30,000 and 40,000 because point A is 0, right? So we are anyway starting from 30,000 and 40,000. So that means point A is already cut. Point A ka dantama kapila ivarai. Clear? Point A is already gone. Understood? Right. So now let's see, right? Don't do anything. Look at what I am doing. Point A is already cut. So let's see from the remaining ones, point B, C, D, and E, which one of these four is your optimum production point, right? Let's see. Now see, the line is going up. Now at this point, B is passed, right? Line past B. Now it's going up, going up. Now at this point, it's past E, past C, and the final point that it is cutting is point D. Again, see, A is already cut. Sorry. Right, A is already cut. So when it goes up at this point, B is cut. Now it's going up. At this point, C is cut. At this point, E is cut. And the final point that it is cutting is point D. Can you see that? Yes or no? Yes. So now what I want you to do. So basically, guys, if the final point that it is cutting is point D, then point D is your optimum production point. Clear? So now what I want you all to do is test it for yourself. Keep your rule on the iso contribution line, move upwards slowly, like how this went, right? See how the line goes up, straight, slowly, right? When it goes up slowly, now point B is cut. Now point E is cut, point C is cut, and the final point is D. Clear? So keep the ruler and move upwards like this, right, in your graph and see whether the final point that is getting cut by the iso contribution line is point D. Tell me, send it to me on the chat. What is the optimum production point that you got? Everyone has to get point D. Optimum production point has to be D, right? Not different people can't get different optimum points. Send it to me on the chat whether you're getting point D. Everyone should get point D. Send it to me on the chat whether you're getting point D. Good, good. Everyone is getting D. Yes. So now circle point D, put an arrow and call it the optimum production point. Call it the optimum production point. Label it as the optimum production point. Right. So in the meantime, let me paste the graph on this. at the exam you will not get to draw this, right? Because obviously you can't draw it in your computer screen. So what the examiner will do is examiner will give you this graph and ask you to interpret. Yeah, examiner will give you this graph and ask you to interpret the graph. You will not be given to draw, you will be given to interpret. Okay, so the next step, right? Again, I have given some space on solving the optimum production, identifying the optimum production point. Step 8, identifying the optimum production point. Keep a ruler on the ISO contribution line and move upwards. And slowly move upwards. The final corner that is cut by the ISO contribution line or the ruler, or in other words, the furthest corner of the is the optimum production point. In this example, the optimum production point is point D. Take this note down, guys. Take down this note. Right. Now, finally, we have the optimum production point. Next, guys, you have to know how to solve. Solving the optimum production point, to obtain the optimum production plan. Okay. So the next step is, guys, you have to solve the optimum production point in order to obtain the optimum production plan. Clear? Right. It's a very lengthy question. Huh? So that's how linear programming questions are. So how do you solve it, guys? Now see, in this graph, now at the what is the optimum production point? Point D, right? Point D. So at point D, what are the two constraints that are intersecting, guys? Tell me. Send it to me. What are the two constraints that are intersecting? Yeah. At the optimum point, obviously, there will be two constraints intersecting, right? So what are the two constraints that are intersecting here? Yes, correct. What are the two constraints? You have the build constraint and you have the maximum demand for Y constraint, right? So in this case, guys, what you can see is out of the two constraints that are intersecting, one constraint is a resource constraint, the other constraint is a demand constraint, isn't it? So in this example, at the optimum production point, there is one demand constraint and one resource constraint intersecting. Clear? Yeah. Now, see, guys, there can be two types of questions, right? Or there can be, yeah, there can be two types of questions or two types of situations. First situation is what you have faced now. At the optimum production point, there is one demand constraint and one resource constraint intersecting. Clear? The second situation that you might face, right, in a question is where at the optimum production point, right, at the optimum production point, there will be two resource constraints, right? At the optimum point, the two constraints are two resource constraints. Either it could be one demand constraint and one resource constraint, or it can be two resource constraints. Clear? Those are the two possible situations that you will face. There will never be a situation where you will have two demand constraints, right? Two demand constraints intersecting will usually not happen. Usually not happen, right? In a question. But normally the two constraints or two situations that you will face is number one demand constraint and one resource constraint intersecting. Number two resource constraints intersecting. One of the two will happen. And the way we solve the two are completely different to each other, right? The way we solve the two situations are completely different to each other, right? So first let me put that note. At the optimum, to solve the optimum production plan and to obtain, optimum production point and to obtain the optimum production plan, we need to check, or we need to understand the two constraints that are intersecting at the optimum production point, right? there could be two possible situations at the optimum production point. First situation is one demand constraint and one resource constraint intersecting at the optimum production point. Second, two resource constraints intersecting at the optimum production point. The way in which the two situations are solved is different to each other. In this example, it is one demand constraint and one resource constraint intersecting at the optimum production point. Okay, right. So the first one, right? If one demand constraint and one resource constraint intersecting at the optimum production point, how we solve is through the substitution method, right? Solve through the substitution method. Second one, if it's one demand and two resource constraint, then the method is solve through linear simultaneous equation, samagami samikaran, right? Solve through linear simultaneous equation. So I'll teach the different methods, but these are the ways in which you solve them. Clear? Now let's solve this point. So at the optimum production point, the two constraints that are intersecting, you have to write the constraints. You have to write the constraints. Build, right? Build what's the build constraint equation, guys? Check the build constraint equation. 20x plus 24x plus 20y equals 1.8 million. So this is one. Second one is demand for Y. So demand for Y, what is the equation? What is the equation? Demand for Y. Demand for Y is Y equals 66,000. That's the equation we use to draw the graph. So these are the two equations. So now what we need to do is solve these two equations to obtain the values for X and Y. Right? So basically, guys, now what are we doing? The whole objective is to find out how much of X units and Y units we need to produce. No? So now by solving these two equations, we will be able to understand how many X units and how many Y units we need to produce. Clear? Now, how do we solve it, guys? How do we solve it? Very easy to solve, no? See, whenever the first situation happens where one demand constraint and one resource constraint intersects at the optimum production point, you will always know either the value of X and the value of Y. You will always know either the value of X or the value of Y. In this situation, again, it's a one demand constraint and one resource constraint intersecting at the optimum point. So in this case, is it the value of X or the value of Y that you already know? You already know the value of Y. How? Because one of the constraints is Y equals 66,000, right? Where you are meeting the maximum demand of Y. So you already know the value of Y. So now the only thing you have to do is you have to substitute the value of Y into the build equation and obtain the value of product X or value of X, right? The value of Y you already know, it's given as Y equals 66,000, right? We already know that. So use this value of Y to substitute into this equation and find out how much is X, right? So the value of Y is already known as Y equals 66,000. Substitute the value of Y equals 66,000 into the build constraint equation and obtain the value of X. Okay. So build equals 24x plus 20 into 66,000 equals 1,800,000. Now, by solving this, you will get the value of X. Clear? Now, you can use your calculator to solve this. I think I have explained how to do this earlier. If not, let me explain again. So how can you solve this? Hold on. Right. So let me explain an easy way of getting this answer through the scientific calculators. Right. Now this is not only for uh, this is not only for a linear programming question. This method of using the scientific calculator could be used for any situation where there is an unknown variable, right? So in this equation, what is the unknown variable? The unknown variable is x, right? The unknown variable is x. So we want to enter this equation into the calculator, right? We want to enter this equation into the calculator and find out the value for x, right? Now listen to this, write this down now. Don't ask me later again. So if you're having this type of a calculator, right? You can see this now. If you're having this type of a calculator, right? You're using this type of a calculator. So first I'm going to teach you all how to do it here. Now my calculator doesn't work, guys, in this one. It doesn't have battery. But I will show you all how to do it. If you have this calculators, please write it down and thoroughly do it in your calculator. Okay. So what we need to do is, guys, we need to enter this equation, right? We need to enter this equation into the calculator. So how do you do it, right? So how do you do it? So first, so we have to enter 24x plus 20 into 66,000 equals 1.8 million, right? So do it with me. Open your open brackets, right? Open brackets, type 24 multiplied by x. Now how do you put x, right? Now here at the top, do you see a button called alpha? Here at the top, do you see a button called alpha? Yeah, here, button called alpha. Yes. So now press alpha and then press the close bracket sign. Press alpha and then press the close bracket sign. First press alpha, then press the close bracket sign. Do you get x? Do you get x? You press alpha and then the close bracket sign. Got x? Right. Close the bracket, and then plus, put enter the plus sign, again open brackets, 20 multiplied by 66,000. 20 multiplied by 66,000, close bracket. Okay. So now you enter 24 in one bracket, you enter 24 multiplied by x. Then in the plus, in the next bracket, you put 20 multiplied by 66,000. Now you have to put the equal mark. How do you put the equal mark? Here at the top, you have the alpha button, right? You have the alpha button. Then below the alpha button, you will have a button called calc. See that? This is the alpha button, right? This is the alpha button. And just below that, you will have the calc button, alpha button, calc button, right? So what you should do is first press alpha and then press calc. Press alpha first and then press calc. Did you all get the equal mark? Did you all get the equal mark? Yes. Okay. Right. Now enter 1,800,000. 1,800,000. Okay. So now you have entered the entire equation, right? So first you open the brackets, 24 multiplied by x. How did you put x? First press alpha, then press the close bracket sign. You got x. Then you close the bracket, plus open the bracket again, 20 into 66,000, close the bracket. Then you put the equal mark. How do you put the equal mark? Press alpha and then press calc. You got the equal mark. Then you entered 1,800,000. Now we have entered the entire equation into the calculator. Okay. We have entered the entire equation into the calculator. Now you have to solve it. How do you solve it? Here, guys, you will see a button called shift. Can you see it? Button called shift at the top here. Below that, you will see a button called calc. Do you see that? You have the shift button and the calc button, right? So how you have to solve is, guys, first press shift and then press calc, right? First press shift and then press calc. Again press shift, again press calc. So shift, calc, shift, calc. Okay? Right, so shift, calc, shift, calc. Shift, then calc, shift, then calc. 2 times. Do you get the answer? Do you get the answer? How much are you getting? Yeah. Okay. I'm getting answers from few. Others also send me. What's the answer that you're getting? Shift calc, shift calc. Right. Good. Good. So you're getting the answer. So the answer that you're getting is x equals 20,000. Right? X equals 20,000. Good. So your practice. So again, now if you're using this type of calculators, this old model, right? This is the old model. You have to be a bit careful, right? Why am I telling you to be careful? Right. I'll show you. Now this is the equation that we entered. No? Now if I make this 1.9 million instead of 1.8 million, now can I get the same answer? Can my answer be 20,000? No, it can't be 20,000 because now the value has changed to 1.9 million. Now enter this new equation that I have put here and see. Enter this new equation with me, right? First only enter the equation. Huh? So this one, 24x plus 20 into 66,000 equals 1.9 million. Just enter it. Don't press any shift calc, just enter it that as it is. So open brackets, 24 multiplied by x. How do you put x? Press alpha and the close bracket sign. You have x. Now close bracket plus again open bracket 20 multiplied by 66,000 close bracket. Now you have to put the equal mark. How do you put the equal mark? Press alpha and then press calc. Right? Then you got the equal mark. Then you enter 1,900,000. 1,900,000. Now you entered. So stop there. Now you entered the equation. Now, how did I tell you to solve it? I told you press shift calc 2 times. Now you must be wondering, why did I tell you to press the shift calc twice? Let's see what happens when you press the shift calc once. Now press shift and then calc once. Press shift and then press calc once. What's the answer you get? Press shift and calc once. What's the answer you get? I got from one student. Others, what's the answer you get? Are you getting 20,000? Yes, you're getting 20,000. So what is 20,000? 20,000 is the answer to the previous question. The previous one where it was 1.8 million, right? So what happens is, guys, when we press shift and calc once, the answer we get is for the previous question that we used the calculator, right? It's the answer for the previous question that we used the calculator. Clear? So now press shift again and calc again. Press shift again and calc again. And tell me now, what's the answer you get? So when you press it for the second time, what do you get? 24,166.66. isn't it? 24,166.67, right? So now you're getting the correct answer. So in this calculator model, guys, always if you're using this method, remember shift calc two times. Shift calc, shift calc. You have to do it twice. If you do it once, you will be in trouble. You get the previous answer. Clear, guys? Any questions on that? Any questions on that? Right. Now let me teach the students who have this model, the new model, right? The new calculator model, right? So if you have this model, right? If you have this model, this is how you have to do it, right? Again, so pretty much similar. Now you have to enter this equation into the calculator. So how do you do it? Open brackets, do it with me and write this down. Open brackets, 24 multiplied by x. How do you put x? How do you put x? Same method. Here at the top, you will see the alpha button. Here at the top, you will see the alpha button. So press alpha and then press the close bracket sign. Press alpha first and then press the close bracket sign. So you got x. Got it? You got x, right? 24 multiplied by x. Press alpha and then press the close bracket. So now you have 24 multiplied by x. Close the bracket now. Close the bracket. Plus, again open the bracket. Again open the bracket. 20 multiplied by 66,000. 20 multiplied by 66,000. Enter and then close the bracket. Right? So now you have entered both brackets, 24 into x plus 22 into 66,000. Now you have to enter the equal sign. So how do you put the equal sign? Here you have at the top alpha button. Just below that you have the calc button. You have the calc button. Yes, you have the calc button. You have the alpha button and the calc button. So first press the alpha button, then press the calc button. You should have equal, right? Press the alpha button and then press the calc button. Did you get? Did you get it? First press alpha, then press calc. You should get the equal mark. So now you have the equal mark. Then after that type 1,800,000. Press the alpha button, then press the calc button. That's how you get the equal mark. Then type 1,800,000. Now you have entered the entire equation into the calculator. Now you have to solve it. How do you solve it? Here at the top, you will see a button called shift. Do you all see it? Button called shift. Below that, there is a button called calc, right? You have the shift, you have the calc. So what you have to do is, guys, first press the shift button, then press the calc button, then press the equal mark, normal equal mark. Shift button, calc button, equal mark. Then it will solve and give you the value of x. X equals, how much are you getting? How much are you getting? Tell me, how much are you getting? 20,000, right? So shift calc equals, shift calc equals. So in this model, it's very simple. You don't have to do it twice. It's just shift calc equals. Whereas in the other model, the old model, shift calc twice. Okay. So going forward, for these type of questions, use that calculator method. Don't waste time trying to do it manually. Okay, clear? So wherever you have any unknown variable, not just linear programming, guys, any question, let it be standard costing or budgeting or activity based costing, any chapter, right? If there is one unknown variable you want to find, you can use this method. Okay, clear? Right. So I will say use the calculator method to solve and obtain the value of x. Right? So once you do that, x or optimum production plan number of x units 20,000 units, y number of y units 66,000 units. So this is your optimum production plan. Clear, guys? Any questions? Okay, right. So now I want you all to take this down. Take down this note, uh, show this and this entire thing. Take this down. If you all have questions, please ask. Right. So that's how you get the answer to a linear programming question, guys. How you get the answer, how you get the optimum production point, right? So see, it's a huge calculation, right? It's a massive calculation. Uh, Fortunately, since it's a computer-based exam, you all don't have to do the full calculation. Those days, where it was a paper-based exam, you had to do this entire calculation, right? Including drawing the graph, right? It usually came as a 20-mark question, but now examiner will give you all the graph and you all will be told to interpret. Okay. So to finish off the question, guys, there is one more thing that the question is asking. The question is asking the maximum profit, right? If you go to the question, the question is asking the maximum profit, right? Maximum profit for the quarter, right? Maximum profit for the quarter. So let's calculate that part also. Yeah. So before I do it, can you all calculate the maximum profit for the quarter? You all know how many units of X we are going to make, 20,000. How many units of Y we are going to make and sell, 66,000. You all know the contribution of 1 unit of X. You all know the contribution of 1 unit of Y. You all know how much of fixed cost is there for 1 month. So calculate the maximum profit for the quarter. Do it, guys, quickly. I'll give you all a few minutes. Calculate the maximum profit for the quarter. Right, let's calculate, guys. The product X and Y contribution per unit number of units right? So contribution per unit of X is $30 and Y is $40, right? We already know that from the question. And we are going to make 20,000 units of X and 66,000 units of Y. Okay. So then the total contribution I earn from X is $30 per unit into 20,000 units. I will earn total of $600,000 of contribution from product X. Then I will earn $40 per unit into 66,000 units, 2,640,000 worth contribution from product Y. That is $40 per unit into 66,000 units. Right? So straight away, I will get to the contribution, because from the contribution, when I come to the contribution, already the variable cost is deducted. So I don't even know the variable cost. So I will directly take from the contribution. So total contribution 600,000 plus 2,640,000. 3,240,000 is the total contribution, but we want the profit, no, right? So from this we need to reduce the total fixed cost, right? So how much is the total fixed cost, guys? They have told us that the fixed cost per month are $650,000 per month. Fixed cost is 650,000, and they're asking us to calculate the profit for the quarter. Quarter means how many months, guys? Quarter means 3 months. So for 1 month, if the fixed cost is 650,000, then for 3 months, how much will it be? That's the calculation. Clear? That will be 650,000. I'll put a minus here. Into 3. 1,950,000. Now, I'm sure most of y'all would have taken just 650,000, which is wrong. Read the question properly. 650,000 is only for 1 month, right? They are asking the question or the profit for 3 months, right? So this 20,000 units and 66,000 units is the sale for the entire quarter, guys, right? Understand that, huh? This is the sales for the entire quarter, not for year or anything. This is for the entire quarter, right? Optimum number of each product which tablet company should make in the next quarter, right? So all this information they have given for the quarter, right? Tablet company is now preparing its detailed production plan for the next quarter. During this period, it expects that skilled labor available will be 30,000, 28, and 12,000. So all this information they have given is per quarter. So that means, guys, number of units they are selling for the quarter, right? So make that very clear. Number of units for the quarter, right? Is that clear? Total profit for the quarter, since it is already in minus, I will just add it. So total profit for the quarter, $1,290,000. Clear? Any questions, guys? Clear on this? Any questions? $1,290,000 is the maximum profit. So now we completed the entire question, right? End to end. Big question it is, right? So good. So now, guys, I all clear on how to do the linear programming calculation and how to get the optimum production plan. If at the optimum production point there is one demand constraint and one resource constraint intersecting, I will fine with it. Any questions at all? I will okay with how to solve the optimum point. Any questions, guys? Right. So now let's take a break. After the break, we have to do the question: if two resource constraints are intersecting at the optimum production point, how do you then solve it, right? So let's take a break, come back, and let's do that question. So now it's 5 o'clock, come back by 5:30 and let's do that question. Okay, come back by 5:30. Right. So let's continue, guys. So like I said, now we know how to solve and get the optimum production plan. If we get one demand constraint and one resource constraint. Now let's understand how to get the optimum production point if there are two resource constraints. So go to the tute and go to page number 12. Go to page number 12. In the tute, go to page number 12. This question, right? So let's go through it. QLJ is planning to expand its product range by producing two new products, product X and product Y. Product X and Y will be produced from different combinations of the same resources. Only product X and Y use these resources. Details of the estimated selling price and cost per unit for each product are shown below. So selling price, material A, $8 per kilo. So these are the cost details: material B, labor, and variable overheads, right? So this is the cost, right? 40, 20, 75, 32, and they have given the rate per hour or rate per kilo as well, right? So total fixed cost of producing X and Y will be $70,000 per month. The management accountant at QLJ is in the process of producing a linear programming model to determine the optimal product monthly production plan for the two new products. The management accountant has established that the following resources are available in each month and has produced the following graph. Resources available: material A, material B, and labor, right? Material A, we will have only 10,150 kilos, B 5,500 kilos, labor 8,400 kilos, right? So these are the resource available. So how many resource constraints are there? All three are resource constraints, right? Because all three has the maximum amount available, maximum resource available limit, right? So I told you last week, if a resource has a maximum available limit, then it's a constraint. Now what you see here is, guys, for product X and product Y, is there a maximum demand? Like in the previous question, is there a maximum demand? No, no maximum demand given for product X and product Y. They haven't mentioned anything. And even in the graph, they haven't shown maximum demand for X and Y. So that means the demand for product X and Y is unlimited, right? The demand for product X and Y is unlimited. And that means product X and Y is demand for product X and Y are not constraints. So there are no demand constraints. There are only three resource constraints, right? There are three resource constraints and no demand constraints. Clear? Any questions, guys? Any questions? Right. So they have given the graph and point A, B, C, D. Those are the points of the ISO contribution line. They haven't marked 0. Ideally, they should mark 0 also. So it should be A, B, C, D, E. But that's fine. Let's go with A, B, C, D. So one of these points will be the optimum production point, right? So then the objective of QLJ is to earn the maximum total profit possible per month from the production of product X and Y. Required, interpret the graph to determine the optimum monthly production plan and the maximum total profit per month from X and Y. Right? Okay. Right. So the first thing I want you all to do is, guys, now they have given everything. They have given the graph, feasible region, and the ISO contribution line. So this is a possible exam question. Like this graph is given, you have to interpret. So what I want you all to do is, guys, now using the ISO contribution line, find the optimum production point, right? Find the optimum production point. Then after that, get the constraint equations of the two constraints intersecting at the optimum point. First of all, find out whether the optimum point is A, B, C, or D. After that, once you find out what point it is, there are two constraints intersecting. No, there are two resource constraints that are intersecting at the optimum production point. So for those two constraints, I want you all to write the constraint equation. Just like we wrote for the previous one, 24x plus 20y equals 1.8 million, something like that. You have to write, I want you all to write the two constraint equation for the two resources intersecting at the optimum production point. Do it. First, find the optimum production point, then write the equation of the two constraints intersecting at the optimum production point. Clear? Do it quickly. Right, let's go through it. So first of all, tell me guys, at the optimum production point, what is the optimum production point? Is it A, B, C or D? Send it to me. Yeah. Yes, optimum production point is point C, right? So when you keep a ruler and when you move upwards on from the ISO contribution line, the furthest corner of the feasible region that is cut, or the corner that is cut last by the ISO contribution line, is point C. Right? Okay. So right. Next, at optimum production point, now let's understand what are the two constraints that are intersecting, right? So at optimum production point, uh, C, so what are the two constraints that are intersecting, guys? What are the two resources? You have material A and you have labor. Material A, so material A, and this is labor, right? No, material, yeah, labor, yes. Material A and labor. The last corner that gets cut is point C, right? All corners get cut, but the last corner that gets cut is point C. So you have to take point C as the optimum production point, right? So material A and the other one is labor. Right, now we have to put equations for this. How do you put equations? They haven't given you the equation. So you have to construct the equations of these two, right? So how do you construct the equations? You have to go to step number 3 and you have to formulate the constraints, right? So I'll put here formulating the constraints. You have to go all the way to step 3, right? So let's formulate the constraints. Material A. Now, to produce 1 unit of product X, how much of material A do we need? How much of material A do we need? 1 unit of product X takes 40 one unit of product X incurs $40 of material A cost, and 1 kilo of material A is $8, right? So then the question is, guys, if 1 kilo is $8, how many kilos do we have to use in order for the material cost to be 40, right? So basically we have used 5 kilos, right? So let's put that. So 40. So first let's put like this. Product X product X product Y per unit. This also per unit. So 1 unit of X, 1 unit of Y. Material A. To produce 1 unit of product X, how many kilos of material A do we have to use? The cost is $40 per unit, right? $40 per unit is the cost, divided by $8 per kilo. $8 per kilo. $40 per unit divided by $8 per kilo. So that means 5 kilos per unit. Then look at product Y. Product Y, the material A cost is $16 and each kilo is $8. So for 1 kilo, if we are paying $8 for the cost to be $16, how many kilos? 2. Right? $16 per unit divided by $8 per kilo. Right? So that will be 2 kilos per unit. Okay. Then the next one we need is labor. Labor, take product X. Labor cost is $75 and every hour I have to pay 25. Right? So if every hour is $25, how many hours do I have to use in order for the cost to be $75? 3 hours, right? $75 per unit divided by $25 per hour, right? So that will be 3 hours per unit. Similarly, product Y, the labor cost is $100 and each hour costs me 25. So if 1 hour is $25, how many hours have I used for the cost to be 100? 4 hours, right? So $100 per unit divided by $25 per hour. 4 hours. Clear? So now that we have established that, now let's construct the constraint equations, right? So material A, to produce 1 unit of product X, we need 5 kilos. And how many units of product X are we going to produce? We don't know. That's what we are trying to understand. Remember, because we don't have the optimum production plan yet, no? So we don't know. So we leave it as X. Plus, to produce 1 unit of Y, how many kilos do we need? Of material A, 2 kilos. So 2 kilos per unit multiplied by how many units of Y? We don't know. Until we get the optimum plan, we don't know. So the amount of material A required for product X plus the amount of uh, material required for product Y should be what? Less than or equal to how much? Less than or equal to how much? The maximum amount of material A available. How much is the maximum amount of material A available? 10,150 kilos, right? So the amount required for product X plus amount required for product Y cannot exceed 10,150 kilos because that is the maximum amount of material A that we have. Clear? Right. Now guys, remember we made an assumption for the purpose of drawing the graph. For the purpose of drawing the graph, we will assume that the entire amount of the resource is used. And therefore, instead of using the less than or equal sign, we will use the equal sign. Remember? Yeah. So therefore, we will say then material A, if we simplify, is 5x plus 2y equals 10,150. So this is the constraint equation of material A, right? So right, so refer the note. I'm not going to write it again. You have to refer the note uh, that I gave earlier last week, right? So I will take it here, right? So if anyone missed the last week class, please go through the class recording, huh? Otherwise you will not understand anything. Clear? Right. Similarly, now let's do labor. So labor, to produce 1 unit of X, we need 3 hours, right? 3 hours per unit into the number of X units plus 4 hours per unit into the number of Y units. So the total amount required for X plus total amount required for Y should be less than or equal to 8,400 hours, which is the maximum amount of labor hours available. Clear? Any questions? Clear? Any questions? Right. Then for the purpose of drawing the graph, remember we said we are assuming that it's equal because the equation, this point, right? At this point, at the optimum point, you have to draw the equation that we use. You have to write the equation that we use to draw the graph. No, so you have to put the equal sign always, right? So 3x plus 4y equals 8,400. So this is the equation of labor. Clear, guys? Any questions? Right? So now what we have here, right? Right? So this is your equation 1, simultaneous equation 1, and this is your simultaneous equation 2. Okay, equation 1 and equation 2. Now you have to solve these two equations in order to get the answers for product A and product X and product Y. To get the optimal production point, you have to solve this. Okay, so two simultaneous equations, right? So now I'm going to teach you all a calculator method again to get the answer to this, right? To get the answer to this. But before I calculator method. Okay. So now when you put into the calculator method, you will need to understand few things. Calculator will ask you something called A, something called B, something called C, right? And calculator will also ask you something called 1 and something called 2. So what are these A, B, C, 1 and 2, right? So if you put into the equation, guys, right, the value in front of X, value in front of X in the first equation, right? The value in front of X in the first equation is called A, right? A1. A1 is called value in front of X in the first equation. Clear? Then B1 means value in front of Y in the first equation, right? Now if we look at A1, how much is A1? This is the first equation, value in front of X is 5. So how much is A1, guys? 5. Then B1, value in front of Y in the first equation. So first equation, value in front of Y is 2, right? Then what is C1? C1 is basically the value after the equal sign in the first equation, right? Value after the equal sign in the first equation. So how much is that, guys? First equation, value after the equal sign, 10,150. Clear? So the same thing, yeah, same thing in the second equation. Instead of first, it's the second. Clear? So this is the meaning, guys. Okay. Now let's put in the value. A1 is 5. B1 is 2. C1 is 10,150. A2 is how much, guys? 3. Right? Value in front of X in the second equation. Value in then B2, value in front of Y in the second equation. 2. Sorry, 4. Then C2, value in front after the equal sign in the second equation, 8,400. Clear? So these are the numbers you need to remember in order to input to the calculator. Clear? Any questions? Right. So in the two different calculators, now I'm going to show you all how to get the answers. Okay. So first, I'll take the old calculator. I'll take the old calculator, this one. So those who are having this calculator, do it with me. Now I don't have, this is not working. I don't have the battery. So I might ask questions. Just tell me what you get. Huh? Okay. So, and write this down, right? If you have to solve simultaneous equations at the exam, you need to know the calculator method, guys. Don't waste time doing manual method. So write it down. So now here, there is a button called mode at the top, button called mode. So press mode once, twice, and 3 times. So when you press the mode once, twice, 3 times, when you press the mode 3 times, do you get something called EQN? Do you get something called EQN? Everyone let me know, do you get something called EQN? EQN means equation. Are you all getting that? Okay, yes, you all are getting that, EQN, right? So write it down. Huh? Press mode 3 times, right? Then you will get EQN. Is the number in front of EQN 1? EQN, there is a number below that, no? Is it 1? Okay, it's 1, right? So then EQN, you will see 1. So to select that EQN, you have to press number 1. In the calculator, press number 1. Number 1, just like that, press 1. So when you press 1 and when you go into the EQN mode, they're asking what? They're asking the number of variables. Are they asking the number of variables? Yes or no? Yeah, they're asking number of unknowns, right? They're asking number of unknowns. Yes. So how many unknowns are there, guys? How many unknowns are there? 2 unknowns, X and Y. 2 unknowns are there, X and Y. So you type 2. Type 2. Now, the moment you type 2, you will be taken to a screen where they are now asking A1 and a question mark. Is that correct? Yes, they are asking A1. So what is A1, guys? I have told you A1 is the value in front of X in the first equation. So how much is that? 5. So type 5 and press equals. Type 5 and press equals. The moment you type 5 and press equals, they will ask for B1. Yeah, they will ask for B1. So when they're asking for B1, what is B1? The value in front of Y in the first equation, which is 2. So type 2 and press equal. The moment you do that, they will ask for C1. What is C1? The value after the equal sign in the first equation, which is 10,150. So type 10,150 and press equals. The moment you do that, they will ask for A2. What is A2? The value in front of X in the second equation, which is 3. Type 3, press equals. The moment you do that, they will ask you B2. B2 is what? The value in front of Y in the second equation, which is 4. So type 4 and press equals. The moment you do that, they will ask for C2. What is C2? The value after the equal sign in the second equation, 8,400. So type 8,400 and press equals. The moment you do that, automatically you should now receive the value for X. Are you getting the value for X? How much is X? 1,700 units. Again press equals. Again press equals. Then you should get the number of units for Y. How much is Y? 825. Clear? So that's how you get the answers for linear simultaneous equation in this calculator method, right? Now remember guys, you're in the equation mode, right? Once you're done with this question, you have to move out of the equation mode and back to the normal mode. So how do you move back to the normal mode? How do you move back to the normal mode? The same way you went in, press mode and press 1. Press mode and press 1 and you will be back to the normal mode. Okay, you're back to the normal mode. Clear? Right, so that's how you do it in that calculator. Now let's quickly do it in this new one. So in this one, how you do this is relatively simple. So if you're having this sort of a calculator, this type of a calculator, this is what you have to do. Press mode. Yeah, here you will have a button called mode. Press mode. And then you get a whole list of things. No, in that, look at number 5. Once you press mode, look at number 5. Number 5 is EQN, right? Equation. Number 5, EQN. So select number 5, EQN, equation. Now when you select number 5, they will ask for, they have given a series of equations, right? From this series of equation, you have to select number 1, A, B, C, where it says A, B, and C. Select number 1. You have to select the first equation. First, you have to go into EQN, number 5. Then from that, you see a list of equation. In that, you have to select number 1. And the moment you select number 1, you will be taken to a table, right? Columns are A, B, C, rows are 1 and 2. Basically, the same table that we filled here. The same table that we filled here, right? So you just have to enter it. So now the cell that has been selected is A1. So A1, type number 5 and press equal. Then it will automatically move to B1, type number 2 and press equal, right? Then it will automatically move to C1, type 10,150 and type press equal. Yeah, then it will automatically move to A2, type 3 and press equals. Then it will move to B2, type 4 and press equals. Then it will move to C2, type 8,400 and press equals. Now you have entered everything. Now press equal again. The moment you do that, you will see x equals 1,700. Are you seeing that? X equals 1,700. Yeah. Okay. Again, press equals. Now you will see y equals 825. Clear? So now you have the answer for x and y in the simultaneous equation. Now again, once you're done with this question, you have to move back to the normal mode. How do you move back to the normal mode? Same method. Press mode and press 1. Press mode and press 1. You will be back to the normal mode. Clear? So if you have to solve linear simultaneous equations, guys, this is the method to use. Clear? Any questions on that? So now we have solved the optimum production plan. Right, we have solved the optimum production and we have obtained the optimum production plan. Now what I want you all to do is, guys, quickly get the profit. They are also asking for the profit, no? Maximum profit. Get the maximum profit quickly. Right. So we have the product. I'll just use the same format. Right. So products X and Y. Contribution per unit of X. So that we have to calculate. Yeah. So let's quickly calculate the contribution per unit of X. We have product X, product Y. Selling price per unit. X is 229, Y is 260. Minus variable cost per unit. So variable cost per unit, you have material A, material B, labor, variable overheads. So material A 40 and 16, material B 20 and 60, labor 75 and 100, variable overhead 32, 48. Oh, sorry. Product X $62 per unit, product Y $36 per unit. Clear? Yeah. Number of units we are making 1700 units of product X, 825 units of product Y. So contribution earned from product X will be 62 into 1700. That is $105,400. Then from Y, 36 per unit. into 825 units, 29,700. That will be right. So total contribution. From this, we need to minus the total fixed cost, which is 70,000. Then you arrive at the total monthly profit. 65,100. Clear, guys? So that's how we solve the graph and get the optimum production plan if two resource constraints are intersecting. So if it's one resource and one demand, we use the substitution method like we did here. Yeah, like we did here. And if it's two resource constraints, we use the linear simultaneous equation method like we did here to get the optimum production plan. Clear, guys? So are you all okay with this? Any questions at all? Please tell me. Are you all okay with this? Any questions? This is very, very important, guys. Huh? Very important to understand. So if you missed the last week's class, please go through the last week's class recording. You can get it from Anushan. You have to send him a message. You will get it, right? Send a message to him separately on WhatsApp. You will get it, right? Go through the recording, understand it, and go through today's recording also so that you will understand it better, right? So we are done, guys, with about 70% of linear programming, right? There are two more areas to complete, right? It's a huge area. Two more areas to complete called slack and shadow pricing, right? So we have to do questions also on that. So next week's focus will be on that, right? So hope everyone is fine with what we did today, drawing the graph, feasible region, ISO contribution, finding the optimum point, solving the optimum point, getting the optimum plan and the maximum profit using both ways, right? So hope everyone is okay. Let me know if you all have any questions. Right, so we can finish off the class for today, guys, right? So I will see you all next week.